Imagine turning on a garden hose for just 5 seconds. Crystal clear water rushes out so effortlessly that you barely give a second thought. But here's what nobody tells you. Before that water ever reaches your flowers, your car, or your backyard, it travels through one of the most carefully engineered products hiding in plain sight. A modern garden hose may look simple, yet it survives scorching summer heat, freezing winter nights, crushing pressure, ultraviolet sunlight, twisting, dragging, and years of constant abuse. Think about this. Every year, factories around the world produce hundreds of millions of garden hoses, stretching a combined distance that could wrap around Earth's equator many times. Inside those factories, molten plastic flows like glowing rivers, while massive extrusion lines operate 24 hours a day with astonishing precision. The smell of warm polymers fills the air, motors hum without stopping, and every second another perfectly formed hose emerges from machines worth millions of dollars. And this is where it gets truly extraordinary. What looks like nothing more than a flexible tube actually contains decades of engineering, advanced chemistry, automated robotics, and some of the strictest quality standards in manufacturing. Before this journey ends, you'll discover how raw oil buried deep underground transforms into a product trusted to carry thousands of liters of water year after year. What happens inside the first machine surprises even experienced engineers. Most people assume a garden hose starts with rubber. It doesn't. Most modern hoses begin their life as tiny plastic pellets made primarily from polyvinyl chloride, better known as PVC, or from advanced thermoplastic elastomers. These pellets may measure only 3 to 5 millimeters across, but each one contains carefully balanced ingredients that determine flexibility, strength, color, and even how the hose behaves after years under the sun. The story begins thousands of kilometers away. Crude oil extracted from countries such as the United States, Saudi Arabia, Canada, and the United Arab Emirates travels to massive petrochemical complexes. There, temperatures exceeding 850 degrees Celsius or 1,562 degrees Fahrenheit crack hydrocarbon molecules into smaller building blocks like ethylene. Those chemicals eventually become the polymers that form the backbone of nearly every modern garden hose you can buy. But PVC alone would create a hose that's too stiff to bend around your garden. Engineers solve that problem by blending plasticizers, stabilizers, lubricants, UV inhibitors, and carefully measured pigments into every batch. Some premium formulations contain more than 15 individual ingredients, each added within fractions of a percent, because even tiny changes can dramatically affect flexibility, lifespan, and burst strength. Then comes one of the hose's hidden superpowers: reinforcement fibers. Depending on the design, manufacturers use braided polyester yarn or knitted synthetic fibers produced in textile mills across countries like China, Germany, India, and South Korea. Those fibers may look like ordinary thread, yet they allow a hose to withstand working pressures of 8 to 20 bar and burst pressures that can exceed 30 bar without splitting apart. Even the shiny metal fittings have an incredible journey. Brass often begins as copper mined in Chile and Peru, blended with zinc from Australia, China, or Kazakhstan. Inside modern foundries, furnaces heat these metals above 930 degrees Celsius, creating an alloy strong enough to resist corrosion while remaining soft enough for precision machining. That familiar golden connector at the end of your hose represents an entire global supply chain hiding in your hand. Every shipment arriving at the factory undergoes strict laboratory testing before production begins. Technicians measure melt flow index, moisture content below 0.1%, tensile properties, density, and chemical purity. Powerful spectrometers confirm metal composition, while computerized analyzers inspect polymer consistency. One contaminated shipment could ruin tens of thousands of hoses before anyone notices. So manufacturers inspect every batch with remarkable discipline. Yet manufacturing these materials comes with a price. Petrochemical production consumes enormous amount of energy, while mining metals reshapes entire landscapes. That's why many factories now incorporate recycled PVC, renewable electricity, closed-loop cooling systems, and formulations that reduce harmful additives without sacrificing performance. The industry continues searching for ways to build stronger hoses, while leaving a smaller footprint on the planet. Everything you've seen so far has happened before a single hose even exists. Mountains of carefully engineered materials now wait beside machines that can transform loose pellets into hundreds of meters of perfectly shaped hose every single hour. But here's the mystery that keeps engineers awake at night. How do you turn thousands of tiny plastic beads into one flawless tube without a single weak spot? The answer begins with a machine hot enough to melt rock. And that's where our factory journey truly begins. The moment has finally arrived. Thousands of plastic pellets cascade into a towering stainless steel hopper, sounding like heavy rain striking a metal roof. Gravity pulls them into the heart of the extrusion line, where a massive steel screw nearly 2 meters long begins rotating at 40 to 120 revolutions per minute. You can't see it from the outside, but inside that heated barrel, one of manufacturing's most elegant transformations is already underway. As the screw rotates, it pushes material through several heating zones. Temperatures gradually rise from around 150 degrees Celsius, 302 degrees Fahrenheit near the feed section, to approximately 190 to 210 degrees Celsius, 374 to 410 degrees Fahrenheit near the die. Friction, compression, and heat work together until every tiny pellet melts into a smooth, glowing stream of polymer that looks almost like thick honey. The air carries the unmistakable scent of warm plastic, while powerful cooling fans hum in the background. Think about this. Every second, sensors monitor temperature within just a few degrees, because even a slight fluctuation can weaken the hose. Too hot, and the polymer begins to degrade. Too cool, and it won't flow evenly through the die. Engineers constantly adjust heaters and screw speed to maintain a perfectly balanced process that can produce more than 300 meters of hose every hour. Now comes the first magical moment. The molten material reaches a precision-engineered steel die, where pressure often exceeds 150 bar, or nearly 2,200 psi. In an instant, the liquid plastic transforms into a perfectly round hollow tube. It emerges glowing warm, soft enough to bend with a finger, yet already carrying the exact dimensions that engineers designed months before production ever began. But here's what nobody tells you. At this stage, the hose is surprisingly weak. If you pulled on it now, it would stretch like soft taffy. That's why it immediately enters a sophisticated reinforcement station, where dozens of high-speed carriers weave polyester yarn around the tube at speeds exceeding 150 revolutions per minute. The rhythmic clicking of the braiding machine fills the factory as hundreds of fibers lock together into an incredibly strong protective mesh. What happens next surprised even experienced engineers when they first witnessed it. Another extruder applies a second molten layer over the braided reinforcement, sealing every fiber beneath a perfectly smooth outer jacket. The two layers bond together while still warm, creating a flexible composite structure that resists abrasion, sunlight, and internal water pressure all at once. The transformation happens continuously, meter after meter, without a single pause. Now the hose races into one of the coolest parts of the factory, literally. It enters a long vacuum calibration and cooling tank filled with circulating water maintained between 15 and 25 degrees Celsius, 59 to 77 degrees Fahrenheit. Vacuum pressure gently pulls the soft hose against precision sizing sleeves, while cold water rapidly removes heat. Within just 30 to 90 seconds, the once molten plastic becomes rigid enough to hold its final shape forever. Powerful haul-off machines grip the cooled hose with synchronized rubber belts and pull it forward at precisely controlled speeds, usually between 0.5 and 2 meters per second depending on the hose size. The motors never jerk or hesitate because even tiny speed changes could alter wall thickness. Every movement feels perfectly choreographed, almost like watching a mechanical ballet performed by machines weighing several tons. Laser measurement systems constantly scan the moving hose thousands of times every second. They verify outside diameter, wall thickness, and roundness with tolerances often tighter than plus or minus 0.2 millimeters. If anything drifts outside specification, computers instantly alert operators or automatically adjust the extrusion process before defects can multiply. Most people never realize that invisible beams of light protect the quality of every hose they buy. The endless hose now reaches an automated flying cutter that matches the line speed before making a perfectly square cut in a fraction of a second. Standard lengths of 15, 25, 50, or even 100 meters slide onto conveyors without interrupting production. The sharp hiss of pneumatic cylinders blends with the steady rhythm of motors, creating a sound that echoes through the entire factory floor. Yet the hose still isn't finished. Skilled technicians and automated assembly stations now attach precision machine brass or durable polymer fittings using hydraulic crimping machines generating forces exceeding 50 tons. In just a few seconds, the connection becomes strong enough to resist years of twisting, pulling, and thousands of cycles of water pressure. It looks effortless, but every crimp must land within incredibly tight tolerances. Standing at the end of the production line, you finally see what began as tiny plastic pellets become a finished garden hose ready for homes around the world. But one enormous question remains unanswered. How do manufacturers know this hose won't burst the first time someone turns on the water? The answer lies inside a testing laboratory where machines push every hose far beyond anything you'll ever do in your backyard. And what they discover is astonishing. The production line may look complete, but this is where the real challenge begins. Every finished garden hose must prove it deserves to leave the factory, because one tiny defect could mean a leak, a burst, or years of frustration for the customer. Most people never see this hidden world of testing, where machines deliberately try to destroy products that took hours to create. What happens next feels more like a scientific experiment than a factory process. The first stop is an automated laser inspection station. As every hose moves along the conveyor, high-speed laser scanners and AI vision cameras inspect the entire surface thousands of times every second. They search for scratches, bubbles, color inconsistencies, tiny dents, or wall thickness variations as small as 0.1 millimeters. If the system detects even the slightest imperfection, robotic arms immediately divert that hose from production line before it reaches packaging. Now comes the test every engineer respects. One end of the hose is sealed while powerful pumps fill it with water under controlled conditions. Pressure climbs steadily from normal operating levels of around 10 bar to extreme burst test levels that can exceed 30 to 40 bar, or nearly 580 psi, depending on the hose design. You can hear the steel test frame creak as enormous forces build inside what looks like an ordinary garden hose. But pressure alone isn't enough. Computer-controlled endurance machines bend, twist, and flex hoses through tens of thousands of cycles, simulating years of real backyard use in only a few days. Rollers repeatedly coil and uncoil the hose while sensors monitor every movement. The steady rhythm of motors echoes through the laboratory, and the smell of warm rubber and machine oil fills the air as the equipment works around the clock. Sunlight can damage plastic over time, so manufacturers recreate years of outdoor exposure inside accelerated weathering chambers. Powerful ultraviolet lamps shine continuously while temperatures cycle between intense heat and cool conditions, compressing years of aging into just a few weeks. Engineers compare color, flexibility, and strength before and after testing to make sure the hose won't become brittle after countless summers. Extreme temperatures create another hidden challenge. Some hoses spend hours inside freezing chambers at minus 20 degrees Celsius, minus 4 degrees Fahrenheit before technicians immediately test their flexibility. Others enter heated rooms exceeding 60 degrees Celsius, 140 degrees Fahrenheit, to ensure they won't soften or deform during the hottest summer afternoons. Watching a frozen hose bend without cracking feels almost impossible, yet premium designs accomplish exactly that. And this is where human experience still outperforms technology. After every automated inspection, skilled technicians run their hands along selected hoses, checking texture, flexibility, and finish with remarkable sensitivity. Experienced inspectors can often feel subtle imperfections that machines struggle to interpret correctly. Decades of craftsmanship remain one of the most valuable quality control tools inside the entire factory. Factories also verify compliance with demanding international standards such as ISO 9000 and One Quality Management and product-specific performance requirements. Random samples undergo tensile testing, fitting pull-off tests, dimensional verification, and leak inspections. In well-controlled facilities, overall rejection rates often remain below 2%, yet every rejected hose provides valuable data that improves tomorrow's production. One final machine records every approved hose with barcodes, production data, and batch numbers before robotic arms neatly coil each length for packaging. Automated wrapping systems secure the coils, while printers apply labels that allow manufacturers to trace every hose back to the exact materials, operators, and production conditions used that day. It's an invisible safety net that protects millions of customers worldwide. At last, the finished hose is stacked neatly onto pallets, ready to begin a completely different journey across oceans and continents. They have survived crushing pressure, freezing temperatures, relentless sunlight, and thousands of simulated years of use without failing. But here's the surprise that almost nobody knows. The story of the garden hose is far bigger than a single factory. It connects global trade, billions of dollars, millions of workers, and a history that transformed the way people care for gardens around the world. And that's exactly where our journey goes next. Now step back and look at the bigger picture. The humble garden hose has grown into a global industry worth an estimated $8 to $10 billion each year, serving homeowners, farmers, landscapers, construction crews, and industries in nearly every country. Combined, manufacturers produce hundreds of millions of garden hoses annually, enough to stretch for millions of kilometers if laid end to end. Imagine a single hose reaching around Earth's equator again and again. That's the astonishing scale hidden behind an everyday product. The world's largest producers include China, the United States, Germany, Italy, and India. China manufactures the largest share thanks to its enormous polymer, textile, and metalworking industries, while European and North American companies often specialize in premium hoses built for extreme durability. Together, these five manufacturing powerhouses account for the majority of global production, supplying retailers and distributors on every continent. Behind every finished hose stand millions of people working throughout the supply chain. Oil and natural gas workers extract raw materials. Chemists develop stronger polymer formulations. Textile specialists weave reinforcement fibers. Foundry operators cast brass fittings. Machine builders design extrusion lines, while technicians, quality inspectors, warehouse teams, truck drivers, and port workers keep products moving around the clock. One simple garden hose represents the combined effort of an extraordinary global workforce. The garden hose has changed dramatically over the past 50 years. Early hoses relied heavily on natural rubber, making them heavy, expensive, and prone to cracking with age. Modern materials such as advanced PVC compounds, thermoplastic elastomers, and high-strength polyester reinforcement have made today's hoses lighter, more flexible, kink-resistant, and capable of lasting for many years with proper care. What once required brute strength can now be lifted with one hand. And the future looks even more remarkable. Manufacturers are investing in recycled polymers, bio-based plastics, AI-controlled extrusion systems, and smart factories that monitor every meter of hose in real time. Some research teams are even developing self-healing polymer materials capable of repairing tiny surface damage before it grows into a leak. The next generation of garden hoses may last longer while using fewer natural resources than ever before. Did you know that a premium reinforced garden hose can safely withstand water pressures several times higher than what most homes will ever produce? Engineers intentionally design a large safety margin, so the hose performs reliably year after year, even under demanding conditions. It's one of the invisible engineering decisions that protects millions of users every single day. Here's another surprising fact. During manufacturing, the finished hose never stops moving. From the instant molten polymer leaves the extrusion die until the final cut, it travels continuously through dozens of machines in one perfectly synchronized production line. If a single station falls behind by even a fraction of a second, the entire process can be disrupted. And one final fact might surprise you most of all. A product that many people buy without a second thought combines chemistry, metallurgy, textile engineering, robotics, automation, materials science, precision machining, and global logistics into a single flexible tube. The next time you water your garden, you'll be holding decades of innovation in your hands without even realizing it. From crude oil buried deep beneath the Earth's surface to precision polymer chemistry, from molten extrusion lines to high-speed braiding machines, from relentless quality testing to global distribution networks, every garden hose carries a story few people ever see. What appears to be an ordinary tool is actually the result of thousands of scientific discoveries, countless engineering decisions, and the dedication of skilled workers across the world. The next time you turn on the water, you'll know that every drop flowing through that hose is supported by one of the most remarkable manufacturing journeys hiding in plain sight. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.